complete the electron configurations for iron 2 plus and the bromide ion. Nice and easy one to start this question off. Just got to be careful that you make sure you're removing the right electrons for the iron 2 ion and spotting that we've obviously got the bromide ion there, so we're gaining 1 electron. We've also been given the 1s2s already, so you can't write abbreviated versions of these. You've got to write the full configurations, otherwise you won't be credited with the mark. So start with iron, find out on your periodic table, check out how many electrons it's got, and obviously then take 2 away because it's a 2 plus ion. Okay, so iron would be 1s2, 2s2, 2p6, 3s2, 3p6. Now it's the 4s2, which would naturally come next, which will be the one that's lost. The rule is whatever fills first, empties first. So in this case, the 4s goes, and you're just left with 3d6 for your first mark. And the bromide ion, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. So normal bromine is 4p5. This is a bromide ion. Add the extra electron on for 4p6. And the next part, predict the products of reacting iron separately with iodine, bromine, and chlorine. Explain your predictions using the electropotential data above. All right, so apologies for only giving you a couple of lines to answer this on the one page, and you have to keep flicking through. So what I'll do, I'll bring an extra piece of paper in a second. So if we look at the electropotentials first of all, so we're looking at the first equation to start off with, because we're asked to look at the reaction of iron with the halogens. So iron to iron 2 has got an electropotential of minus 0.44, so it's negative in comparison to all the halogens which are positive. So this must mean that when you react your iron with any of these halogens, the iron equation is going to go backwards. The iron is going to oxidize to iron 2, and the halogen is going to then reduce to the halide ion. So let's have a look at these individually and see what happens. So first of all, iron reacting with iodine. The iron is a minus 0.44. The iodine is plus 0.54. So the iron is going to oxidize to iron 2, and the iodine is going to reduce to iodide. As you're being asked to predict the products. So if we try and write an equation for this, okay, always put the more positive one on top. It makes it easier to work it out. So iodine plus an electron gives you I minus, and we've got the iron 2 plus ion plus 2e minus gives you iron. So this one's going to go forward because it's more positive, and this one's going to go backwards because it's more negative. Now we need to multiply this equation by 2 because we've got we need 2 electrons in the top equation to cancel out the 2 electrons in the bottom equation. So half times 2 is 1. So our overall equation here is going to be iron plus iodine will produce 2i minus plus Fe2 plus. But the question asked to predict the products. So the products here are going to join together. These 2 ions are going to join together. You're going to get iron 2, 2 plus, to the 2 iodide ions combining to give you FeI2. Okay, so look at the second one. The iron to iron 2, bromine to bromide. So what we're going to have here is the same thing happening. The iron is going to oxidize to iron 2, and the bromine is going to reduce to bromide. However, this is where this question gets a bit sneaky. If you look at the electropotential of the second equation of the bromine equation, you can see it's plus 1.09. Now the iron, when it oxidizes to iron 2, we know iron 2 can further oxidize to iron 3. Now if you look here, the electropotential of the iron 2, iron 3 half equation is still less positive than the bromine equation. So the oxidation of the iron will carry on. It will oxidize to iron 2, and the bromine will continue oxidizing it. This continues acting as an oxidizing agent, and then further oxidize it to iron 3. And the same thing happens with the chlorine, because again, the chlorine is more positive than the iron 2, iron 3 half equation. It's very sneaky, but they like to throw that in there to see if you are really understanding what's happening with these electropotentials. The first one stops at FeI2 because the iodine half equation is less positive than the iron 2, iron 3, so that it can't continue the oxidation. That reaction will stop. But the other two, because they are more positive than the iron 2, iron 3 half equation, the oxidation of iron will go to the iron 2 and then continue to the iron 3. So your other two products will be FeBr3, because we're going to end up with an iron 3 ion, and FeCl3. Very sneaky, very naughty, but be careful and look out for that. It happens more often than you like to think. Now, it does say explain your predictions. So I've just very quickly, because I've only got 2 lines here, I've written the 3 products in. So an explanation of your predictions, it would be a good idea to make some statement about how you know which way the equations will go. So I would say something like, because the iron is more negative than all the halogens, the iron will always oxidize and the halogens will always reduce. That's the best way to explain it. So write a sentence saying that, and that will be under the mark. So, tricky little one, that one. Well done if you got it right.